Okay, we are now going to do an example of a right-tailed test. So in this case, the problem says the national average cost of an overnight stay in the hospital is $10,334. So a sample of 30 Ohio patients has a mean of $11,231 with a standard deviation of $2,856. So we want to test at alpha equals 0.10 whether the true mean cost of a hospital stay in Ohio is greater than the national average. Okay, so this sample is taken from Ohio here, and our hypothesized mean here, I want to see if the mean in Ohio is actually greater than this national average. So this national average is going to be our hypothesized mean, and the null hypothesis would say there is no difference, they're the same. Okay, so the true mean of Ohio is equal to 10,334. So this mu here would be representing the true mean cost of an overnight hospital stay in Ohio. And the null says it is no difference, it's equal to 10,334. And then the alternative here, you're wanting to show if maybe it's actually more in Ohio. And so the alternative would say, no, I think maybe it's greater than 10,334. Okay, so this is the hypothesized mean, and this greater than here means we have a right-tailed test. So when we draw our rejection region, put 0 in the center. Okay, and our alpha in this case is 0.10. Okay, so that's this alpha is the biggest alpha we have so far, which means the results here are the least significant. So that's like 10% chance of committing the type 1 error. So alpha, this is a one-tailed test because it's a right-tailed. So one-tailed alpha 0.10 is right here, and then I go down to the bottom, and my critical value is 1.282, and that'll go right here, 1.282, and that's my critical value. And so if you're bigger than that, you're going to be able to reject H0. Otherwise, if you're less than that, you would fail to reject H0. So the question is, what side of the critical value are we? Okay. So now my test statistic, I got my sample mean is 11,231. Subtract the hypothesized mean, 10,334. Okay, divide that by the sample standard deviation, 2,856, over the square root of 30 patients. Okay, and let's see what our test statistic says. So 11,231 minus 10,334, and then I'm going to divide the difference there in parentheses, 2,856 divided by the square root of 30, and then I actually get 1.72. And in this case, 1.72 does lie in the rejection region. 1.72. So I actually have, at this significance level, I have enough evidence to reject H0. So my decision will be reject H0. And that means I have enough evidence to conclude the alternative. So my conclusion here, I'll go ahead and write it here, there is enough evidence to conclude true mean cost of an overnight, I'm going to just write it all out here, overnight stay at hospital is greater than this amount, and that's the national average. So I can say greater than the national average. So there's enough evidence to conclude that the true mean is greater than the national average. Okay, and I wrote it all out here. Usually I'm pretty good if you would say something like, there is enough evidence to conclude the true mean is greater than, 10,334. I'm just describing what the true mean is. It's the cost of an overnight stay in Ohio. Okay. Oh, and I said stay at hospital. I should have said in Ohio, right? I didn't even say that. In Ohio. So that one's a little wordy. So if you just said there's enough evidence to conclude the true mean is greater than 10,334, that gets the point across. Okay. One thing about this is that this is not a very significance level, and so my criteria for rejecting was not that great. It was easier for this to go past this. If I had a smaller significance level, so this was further out, then very likely I wouldn't have been able to reject it. At the 0.01 significance level, this here would have been 2.326, and then I would not have had enough evidence to reject. So whether you reject or not really depends on your significance level to some extent, depending on how close this critical value is to the cutoffs. And so what you're really doing is you're weighing the evidence, and you're setting up what criteria, how confident you need to be in the result. In this case, how low you need the probability for committing the type 1 error to be. Okay? And then you're checking to see at that significance level whether there's enough evidence to conclude the alternative or not. Okay? I like these three examples because they show you that there's a lot of applications here that you could use this for. The first one, we were testing the claims of a company. The second one, I was checking to see if a value changed over time. And this one, I'm comparing, this like Ohio average to the national average. And so you can use this to do a lot of different things. So it's a very useful tool. So in the next couple videos, I'll have some more examples of hypothesis tests. And I'm going to want you to pause the video and try them yourself before you watch me do them, just to see if you can get the right result. So let's go on to that.